There's a company with billions in the bank, a contract signed by the US government, and a simple goal: build a factory, not overseas, right here. Everything a factory needs, they have: capital, demand, political backing, land. And they still can't do it. Because one of the things they need to buy doesn't exist anymore. Not it's expensive. Not it's backordered. It's gone. The company that made it closed. The people who ran the machines retired. The machines themselves were scrapped. And nobody wrote down how any of it worked. You can't wire money to a thing that no longer exists. This is the part of American manufacturing nobody prices in. We've been told the same story for 30 years, and it's a comforting one. Factories left because labor got cheap somewhere else. A worker in Shenzhen cost a fraction of a worker in Michigan, so the work followed the cheaper hands. Simple. And if that's the whole story, the fix is obvious. Raise the cost of building abroad. Slap on tariffs. Offer subsidies. Make America the cheap option again, and the factories come marching home. Every politician tells a version of this. Left, right, doesn't matter. Bring the jobs back. It polls well because it makes sense. If they left for money, they'll return for money. Except they mostly don't. And when you look at why, the wage story starts to fall apart. Because a factory isn't just a building with cheap workers inside. A factory runs on something you can't see, can't buy, and can't put in a spreadsheet. It's the reason the story is incomplete. Think about the last person at your job who actually knew how everything worked. Not the manual, the person. The one who knew that the machine on the left runs hot in summer, so you start it 20 minutes early. The one who could hear a bearing about to fail. When they leave, the manual is still there, but the knowing walks out the door with them. Engineers have a name for this: process knowledge. It's the undocumented, hands-on skill of actually making a thing, as opposed to designing it. And it doesn't live in blueprints or patents. It lives in people, and in the dense web of suppliers around them. Here's the trap. Process knowledge is almost never written down, because it can't be. How do you write down the exact feel of when a weld is right? The precise sound of a machine that's about to jam? You learn it by standing next to someone who already knows for years. It transfers by apprenticeship, not by PDF. And that means when the people go, the knowledge doesn't get filed away for later. It's simply deleted. A patent tells you what to make. Process knowledge is how you actually make it without ruining 9 out of 10 tries. One is information. The other is a skill that lives in hands and muscle memory. You can email a blueprint anywhere on Earth in a second. You cannot email the 20 years in someone's fingers. If this sounds abstract, look at what happened when America tried to rebuild something it invented. The United States built the atomic bomb. To do it, they manufactured a specific material, codenamed fog bank, used inside certain nuclear warheads. The Y-12 plant in Oak Ridge, Tennessee, made it from 1975 to 1989, then shut the production line down. Not needed anymore. Around 2000, refurbishing those same warheads, the government needed fog bank again. They had the designs, they had the funding. National security was lighting a fire under them. And they could not make it. The manufacturing records were sparse, and the people who'd made it the first time had retired or died. The specifics left with them. So the government first spent about $23 million trying to develop a substitute, and couldn't get one to work. Then they spent roughly another $69 million, essentially reverse engineering the original material, a process they finally completed in 2008. The whole mess delayed the warhead program by about a year. Sit with that. The most powerful, best-funded institution on the planet lost a recipe it wrote itself and had to reinvent it from scratch at a cost of tens of millions of dollars. And it wasn't a one-off. NASA hit the same wall with the F-1 engine, the giant Rocketdyne engine that powered the Saturn V and launched Apollo to the moon. It's still the most powerful single-chamber liquid-fueled rocket engine ever flown, at around 1.5 million pounds of thrust. Years later, when NASA engineers look at reviving the F-1 for a new rocket, they discovered a familiar problem. The blueprints existed. Despite the popular myth, NASA never lost them. What was gone were the people. The engineers who built the thing in the 1960s had retired or died, and the manufacturing techniques they used by hand had fallen out of practice, replaced by nobody, because nobody had needed them in 50 years. So modern engineers had to physically pull old F-1 engines out of museums and storage, take them apart, and 3D scan the pieces just to understand how they were built. They had the drawings the whole time. The drawings weren't enough. The designs were never the problem. The knowing was gone. And once you see it that way, a lot of familiar headlines start to read differently. Every time you hear that a factory is coming back, that some company is reshoring production, that a plant is opening on American soil, the quiet assumption is that we still know how to run it, that the skill is dormant, waiting, ready to switch back on the moment the money shows up. But skill doesn't sit dormant. It dies. And it's been dying quietly for decades, one factory at a time, while everyone argued about jobs. This was never mainly about jobs leaving. It was about an ecosystem of know-how quietly going extinct, and the jobs were just the part we could see. To understand why it dies so completely, you have to see how the pieces connect. Because factories don't stand alone. They sit inside a web of suppliers, and that web is the thing that actually breaks. Picture a factory that makes, say, a phone. It doesn't make everything. It buys screens from one supplier, chips from another, tiny screws from a third. Those suppliers buy from their own suppliers. It's a pyramid, hundreds of companies deep, all clustered close, all trading knowledge every single day. Now pull one block out. Say the cheapest part, the screws, starts getting made overseas. The screw factory closes. Just one supplier, no big deal. But that screw maker also bought specialized steel from a local mill. Lose the screw factory, and the mill loses a customer. And that mill supplied 3 other factories nearby. It's a chain reaction. You didn't remove one company. You removed a customer that kept the next company alive, which kept the next one alive. Then it gets worse because of the tools. Making advanced products requires specialized equipment, and that equipment is itself made by a small handful of specialists who need constant orders to stay sharp. Stop making the component, and you stop buying the tools to make it. So the tool makers close too. Now you've lost not just the ability to make the thing, but the ability to make the machines that make the thing. And underneath all of it, the people. Every one of those companies held workers who trained the next generation. When a factory closes, those workers don't wait around. They retrain. They move. They get a job at the hospital or drive a truck. And the young person who would have spent a decade learning from them never gets the chance. You don't just lose today's expert. You lose everyone they would have taught, and everyone those people would have taught. That's why offshoring one link doesn't cost you one link. It quietly severs the next and the one after that. There's a reason this loss stays invisible until it's catastrophic. Knowledge doesn't just add up. It compounds, and it compounds hardest when experts are packed together. Silicon Valley is the obvious example, but it's the same everywhere. Cluster 1,000 experts in a few square miles, and they leak knowledge constantly. Someone solves a problem at one company. 6 months later, half the region knows the trick. They poach each other, drink together, gossip about what works. The whole cluster gets smarter than any single company could on its own. 1 + 1 makes 3. Scatter those same people across a country, or retire them one by one, and it runs in reverse. The gossip stops. The poaching stops. The knowledge that used to bounce between them just doesn't. Each expert who leaves takes their piece, and the pieces stop connecting. It's slow. A cluster doesn't collapse in a year. The senior people are still around, still competent, and on paper, everything looks fine. But nobody's replacing them. The pipeline dried up a decade ago, and no one noticed, because the loss doesn't show up until you actually need the next generation. And there isn't one. By then, it's not a gap you can hire your way out of. It's a hole where 20 years of accumulated skill used to be. America has thrown money at exactly this problem. The CHIPS Act, signed in 2022, put $52.7 billion toward bringing semiconductor manufacturing home, including $39 billion in direct manufacturing incentives. And money like that is genuinely good at some things. It builds buildings, it buys machines, it pours concrete fast. What money can't do is buy the 20 years of experience that a chip fab needs running inside it. Advanced factories need engineers who've personally watched 1,000 things go wrong and know how to fix each one. In Taiwan, those people exist in enormous numbers because the work never left. The knowledge kept compounding while ours scattered. In America, in many of these fields, that generation is thin or simply gone. You can build a gleaming fab in Arizona in a couple of years. Staffing it with people who actually know how to run it is the part the money can't rush. When TSMC built its plant in Phoenix, it had to push production from 2024 to 2025, and the chairman said plainly that the delay came down to a shortage of skilled workers with the specific expertise to install semiconductor equipment. The company ended up flying in around 500 experienced technicians from Taiwan just to train the local workforce. The building went up fine. The know-how had to be imported. Rebuilding that expertise for real is brutal and slow, and nobody wants to hear the price. It means apprenticeships that take years. It means making things badly for a while, accepting that your first batches will fail, and your second, as people slowly relearn what was lost. When Rocketdyne first built the F1, they fought so much violent instability in the engine that combustion kept destroying the test hardware, and they only solved it through a long, grinding trial and error campaign. That's what earning process knowledge actually looks like. It means tolerating failure long enough for skill to grow back. And that runs directly against how modern companies work, where a plant is expected to turn a profit fast, not spend a decade quietly getting good again. You can't shortcut it, because the knowledge only comes from doing the thing wrong over and over until you learn to do it right. We've spent decades believing that if we ever really wanted to build things again, we could. That the ability was ours, banked, waiting. That the only questions were cost and will. But a country can have all the money in the world, every incentive lined up, total political agreement, and still be unable to make what it once made in its sleep. Not because it forgot the designs, because it lost the people and the clusters and the quiet apprenticeship that turned knowledge into skill. Wealth and desire aren't enough when the thing you need to buy is 30 years of somebody's life, and nobody spent those years. The factory is still waiting. And the real question isn't whether America can afford to build things again. It's whether we're willing to be bad at it for as long as it takes to get good, or whether we've forgotten that being good at something was ever a thing you had to earn. Money was never the hard part. The hard part is time. And that's the one thing you can't reshore.